Problem 7. So in this problem, we're told that your kettle requires 1,500 watts to run. So we've got that the power is 1,500 watts. You fill it with 1 litre of water. So the mass of water is 1.0 kilograms. And the initial temperature is 21 degrees C. And we're asked, how long does it take your kettle to boil? So we'll need to make use of a couple of equations to answer this. We know that the power used is equal to the energy over the time, so energy in the form of heat in this case. So we can rearrange this to put Q is equal to PT. Now we know that that heat goes into changing the temperature of the water. So for heating water, we know that Q is equal to mc times the change in the temperature. So we can now use this equation to work out the time. So the lowercase t stands for the time, the capital case T stands for the change in temperature here. So the time is equal to mc times the change in temperature over the power. Okay, so now we know what all these things are, so we can substitute in. So we've got that the mass of water is 1 kilogram, the heat capacity of water is 4,186 joules per kilogram per Kelvin. The change in temperature, the final temperature is 100 degrees C if it's going to be boiling, and the initial temperature is 21 degrees C, and the power used by the kettle is 1,500 watts. So that's a relatively low power for a kettle, so a slowish kettle. And so solving this on the calculator, you end up with 220 seconds. So that's one way to answer it. Alternatively, we could convert this into minutes. Now, 3 times 60 is equal to 180 seconds, and 4 times 60 is equal to 240 seconds. So it's not quite 4 minutes, so it's something above 3 minutes. So this tells us that it's 3 minutes. And then to get the number of seconds, we'll have to subtract 180 from 220, and that leaves 40 seconds. So we could write this as 3 minutes and 40 seconds if we wanted to, or we can just leave it as the 220 seconds.